before you start to do anything with this one, all right, I would probably algebraically manipulate this. All right, change it from radical form to exponential form. All right, so I'm not taking the derivative, so I'm not going to do f prime of x. I'm just going to come down here and go, oh, this really is an x squared minus 1 raised to the 2/3. The root always goes in the denominator. This always is in your numerator. So I would pull it up there so that we can, again, see that power rule real easy. Okay, so we've done derivatives like that. Not a big deal. All right, now I'm ready to start. F prime of x. All right, and it's all it is a good old-fashioned power rule. All right, so pull that 2/3 down front. Leave the inside alone. 2/3 minus 1. Be a negative 1/3. And then times d dx of the x squared minus 1. All right, now on this one, I'm probably, I can do it at any point in time, I guess. Let's do it later. Let's leave the 2/3 alone and the x squared minus 1 to the negative 1/3. Let's just leave that alone for right now and focus on the derivative here, which will just be 2x. All right, now this negative 1/3, what? I can move to the bottom and make it positive, right? Because we don't want negative exponents. So that's going to go to the bottom. This 2 and this 2x is in the top already, over 1. All right, so I'll have 4x in the top. I'm going to have the 3 that's already in the bottom. I'm going to move this. Now, when I move it down, since I had a cube root to begin with, I'll move it down. The exponent becomes positive. Let's go ahead and write it as a cube root of an x squared minus 1. Okay, I mean, if you wanted to put an extra step in there and writing the x squared minus 1 to the 1/3 power in the bottom and then changing it to the cube root would work. All right, but if not, then that works that well as well. All right, now let's do one more and talk you through it and see how you would do this. All right, let's say you've got an f of x. Maybe you had, say, a negative 7 on top, and you had a 2x minus a 3 squared. Now, we see a quotient, right? However, don't we agree that quotient rule is harder than product rule? Okay, quotient rule is harder than product rule. I have a chain. The chain's in the bottom. Here's my inside, and then I've got something raised to the second power. And yes, I could do quotient rule. All right, I'm guessing the algebra would be pretty nasty. All right, so could I take this and move it to the top and make the 2 negative, and then make the problem a whole lot easier to calculate a derivative? All right, so negative 7, 2x minus 3 to the negative 2. All right, I'm just thinking that would be a whole lot easier. So algebraically manipulate that before you start. Think about what you got. F prime of x. All right, so power rule. So pulling that negative 2 down in front is going to give me a 14. Leave the inside alone, 2x minus 3. Subtract 1 here, negative 3. And then times the derivative of that inside. All right, so again, I've got a 14, a 2x minus 3 to the negative 3rd, which I'm just going to leave alone in that step. Take the derivative here, which is just a 2. All right, now the 14 and 2 is 28. This is going to go to the bottom, so I'll have a 28 in the top, and a 2x minus 3 to the 3rd in the bottom.